Great. Group number 5 is Astra Optics is our next team. It looks like they're getting ready. Coming from the industry 4.0. You have
Thank
3
you.
minutes. Jumpstart your dreams, please.
All right. Hi, everyone. I'm Charu. I'm the CEO and co-founder of Astra Optics Limited. We are commercializing a groundbreaking 3D nanofabrication technology. Take the Eiffel Tower. It's a very complex structure with over 20,000 parts. At that time, it took them over 2 years to make it. We can make this the size of a human hair with parts that are 1,000 times smaller than a human hair. And very precise, very complex parts, and we can do it very fast. So the current 3D nanofabrication technology is very slow. It's like printing 1,000 pages with a dot matrix printer. I don't know if anybody even knows a dot matrix printer. We are the laser printer. We are just better in every possible dimension. And we are the technology of the future. That's what's needed in the industry right now. This technology was developed by Professor Shichi Chen. He's my old friend from MIT. He's developed it here in Hong Kong. It's over 10 years of research, 6th generation technology, over 6 patents. And as I said, this technology is not only faster, more precise, lower cost, and even adds material variety. We can print with semiconductors, metals, polymers, biomaterials, you name it. This is like ChatGPT for nanofabrication. We can build lots of applications on top of it. For example, we can make all these bulky optics very small for cell phones, AR headsets. We can also make anti-counterfeit technology for finance, for luxury goods. We can mass produce it. And this can also unlock lots of technology for the future, for healthcare. Imagine a micro robot going and removing blood clots in your brain. So the possibilities are great. We still need a year or 2 of technology development to customize it. We have lots of traction from suppliers to Apple, Xiaomi, BYD to mass produce things for them. In terms of fundraising, we have a term sheet for seed funding. We are selected for Race Plus, which is a big funding by CUHK, and we are likely to get it from the Hong Kong government as well. Recently, we won the ATech startup competition, so lots of investors are also talking to us. And in terms of the team, we have Shichi himself, we have a great CTO, we have other experts in optics, precision engineering, material science, and I have a lot of experience with startups, hardware, software, as well as manufacturing, and I can really scale the company. I know how to bring products to market. So we are very excited to bring this technology of the future to the world now. Thank you.
Thank you very much. Judges, please.
This is Shirley from HSBC. I was just wondering, are you guys owning the patents, or is that the patents still held by a professor and you guys are just using?
The patents are owned by CUHK. We license them. We have a non-exclusive license now, but we can also get an exclusive license for the patents, yeah.
Hi, Emmanuel from Tiger Trade. So the innovation is in the laser nanopore, or is it in the nanomaterials themselves?
The innovation is in optics, precision engineering, as well as material science. So it's a combination of all those three things, yeah.
Then you are patenting a method of making something, or are you like, well, what is the protected entity? What is the protected asset here?
It's the know-how.
Yeah.
So it's based on over 10 years of research. Let's say $20 million every year. So I mean, it's very difficult to use all these lasers and stages and digital micromirror devices to do what we do. So that's the know-how is really the how to do it is really the technology.
Then what's the first use case of your know-how that you're planning to roll out?
So it's going to be these flat optics and also holograms for anti-counterfeit technology. I can show you some samples like this one. I can pass it around maybe. Actually, you can take a look. So this is like, it's composed of nanostructures which cannot be easily replicated. So I think it can add a lot of value to luxury goods, even security, finance, like banknotes, so on. And the market is actually very big because, too many applications for the future.
Well, what are the current limitation of, you mentioned there is still way to go in terms of funding to get it to production. What is the current limitation that it is? And how does it differ from similar technologies, which is, what are the closest nanotechnology?
So currently this is developed from a research lab. So let me just go ahead. Yeah, so we have to optimize and stabilize the technology to increase the yield and make it really, suitable for industrial applications. So the challenge is to optimize it. I don't think it's a limitation, but it's just a matter of time. It's an engineering problem. And these are some of the competitors. So Nanoscribe is the biggest one. They're not really competitors because they are limited by the speed and the precision. So usually their markets are only academic markets. They cannot scale to industrial production, mass production. Other companies can they're faster, but then they're not as precise. They're maybe 100 times worse. So we are the only ones who can do both precision as well as speed at low cost. So it's quite unique.
Is the intention to license the technology, or is it build the hardware, or to provide this as a service?
So we will mass produce parts directly. So it's going to be more like a service or actually just production. Yeah.
Any other questions by our judges?
Hi, just want to ask that you mentioned that know-how is your competitive edge, right? But how can you make sure that with your know-how you can have a scalable business model, means that you have very efficient and productive ways to serve your customers, say your demand proven to be huge in the future? Thanks.
Sorry, I don't understand the question. Can you explain?
Means know-how sometimes it is how to say, it is hard to do some mass production or something because you need more tailor-made or customized things. So how can you make your productivity high, that you make your cost low and to serve the customer demand?
So we are already optimizing our technology for one application at a time. So I mentioned, we start with these flat optics or flat anti-counterfeit technology, and then build a mass production system on top of that. So that's where we need some work, engineering work, and then to set up our processes, really control the processes to make sure we have high yield for industrial production.
What do you see are the risks for you going forward? You have a technology, you need to develop markets, and there are potentially many applications. What are the major risks in terms of your next phase of growth?
I guess supply chain is the main risk because of geopolitics.
Wrap up in one sentence.
Sure. So we are addressing that by developing local suppliers in mainland China or in this region, so that we don't have to depend on international or Western companies to provide us some of the key parts.
Wonderful. Thank you very much.
Thank you.
Thank you.